Here's what I was planning on doing. I'm gonna kind of pull an audible a little bit, mainly because I sense that about half of you saw this and half of you did not. So if you saw this, this is a good opportunity to be able to get some tickets here and just respond to these answers. So if you didn't watch the podcast on 9.3, I would say just get this down. You may have to go back to really get this concept, okay? All right, here we go. Really dial in. Here we are. As we start this review process, I want to make sure that we're good on each of the concepts on the check your understanding. This is our last thing off the unit, okay? Yeah. All right, here we go. The power of the test to detect a mean increase in TBBMC, which is the true mean percentage change from the exercise program, is an alpha level of 0.05 with a sample size of 25. The power is 0.80. Here's what I want you to do real quick. If you haven't watched the podcast, circle that and tell yourself that you will not have to find this. That number you do not have to find. What you will have to do is interpret, okay? You've got to interpret what that value actually means. So someone real quick, see if you can help me. You can use some of your notes too, or the off the golden nugget up above. What is the interpretation of power?
Oh, it's like the probability of having convincing evidence.
Good. So it's the probability. Give some space because I'm going to put something above that. It's the probability that the test gives convincing evidence for the alternative. Or you could say against the null. Okay? So it's a probability that the test gives convincing evidence for the alternative. So we could probably say this a little bit better in context. Grace, do you have anything
Is
to?
it like exactly the big in the golden nugget? Is it here?
That's exactly it.
Assuming the true mean is 25, there is a 0.8 probability of finding convincing evidence.
Good. Assuming the true mean is 0, because we're using the context, right? Assuming the true mean is 0 for the percent change in TBBMC, there is a what probability? 0.80, because that's the power number, right? Probability that the test gives convincing evidence for the alternative, and I usually try to put what the alternative is that mu is greater than 0. And that is the definition of power. Now, if you say right now, Coach, I'm confused, I would check the podcast out because it literally goes through all of that there. But I just want to make sure we kind of do one minor example before continuing. Number 2, the probability of a type 1 error is what?
The alpha level.
Good. It's the alpha level. Always, always, always. Which in this case was what? 0.05. Good. A probability of a type 2, this was the new one, off the podcast, is equal to 1 minus power. Good. So in that case, what would the 0.2? Good. And you'll need to know how to do that both for multiple choice and FRQs. Just knowing what that would be there. Again, I do not have to solve for power. I just need to interpret it and know that a probability of a type 2 error is 1 minus whatever the power would be. Okay? All right, so far so good. Now, if you haven't seen the podcast, again, I think it's a pretty easy podcast, so don't worry about that. This is just off of that part there. Number 3, determine what would change, whether the power would increase or decrease, and explain your answer. So if I went to an alpha level of 0.01 compared to 0.05, what would happen to my power? If I decrease the alpha level, what would happen to my power, right? It would decrease. Good. So if I decrease the power, or decrease the alpha level, decrease alpha level, the power would decrease. So decrease power.
What?
Cool? Remember, what is power? It's the probability of finding convincing evidence against the null or for the alternative, right? Same thing. So if I decrease the alpha level, is that going to be harder to find something statistically significant? Yes. So therefore, my power would decrease. Does that make sense? That's kind of what we're looking for. What would happen if my sample size went from 100 instead of 25? What would I expect of my power? Power would increase, right? I would have more evidence, would I not? More evidence. So I would say this, as sample size increase, so increase sample size, which was just little n, we would also increase power. Okay? Good stuff. Did you see that here?
Yeah, me here.
Gotcha. Okay. Do that. Cool. Questions here? All right, rocking. I think we've got this next thing. Okay, go ahead to this. I figured this would be really helpful for us just kind of going through and reviewing. Now, I gave 2 review days, today and into tomorrow, to go over FRQs and multiple choice, and then also this behind me, because I think just trying to get our feet back and wet with what we were talking about before is important. Okay? So 9.2, proportion world and mean world. Tell me, what's chapter 9 about? Give me like an overarching, like, chapter 9. Significance test. What was chapter 8?
Oh, it was the confidence.
Confidence intervals, right? Cool. Did you say it?
Yeah.
I can't hear you. You gotta hear. I'm so sorry. All right, so we have a confidence interval into significance tests. All right, significance tests. I will tell you, most important test for this AP exam. Most important. Okay. So let's take a look at this. As we look at this top part, the symbol for the statistic, we're going to look at both worlds, proportion versus mean world. Someone help me. What would be the symbol for the statistic in 9.2 compared to 9.3, Ivana?
P hat versus X bar.
Good. P hat versus X bar. So I'm going to go through all of the different parts here. Ryan, you want to give us the symbol for the parameter? P and? So this is P. What was this? Mu. Good. P and mu. The name of the procedure would be what for each? Let's see, someone here sing it? I like it. We could say one proportion or one sample. Z-test. And over here on the mean world would be a one sample t-test. I like it. Good, good. One proportion and one sample t-test. I like it. All right, the random condition, what do we have to show? This is condition 1. Claudia?
To show that the test has been, the sample has been conducted randomly, like it has to say like SRS or like random in the description.
Nice. Randomly or SRS, and that's for both. Okay? Both are the same. Do these help you while preparing for a test?
Yeah.
Okay, cool. 10% condition. What do we know about that? Kristen, what do you think?
It has to be less than or equal to the 1/10 of the whole population.
Good. And you just make sure you plug it in and show that, right? And this would be the same for both parts. That's condition 2. All right, now this is condition 3, which I think is the most missed part when I looked at the last test. By the way, I don't know if I've said this. That last test was rocking. Y'all rocked on that. 9.1 and 9.2. Y'all did great on that. Did a great job on that. The normal condition for proportion world would stem from what?
Law of large counts.
Law of large counts, good, which is what, Ryan?
Huh?
What's the law of large counts again?
Times P
Good.
is greater than 1 minus P is greater than or equal to.
Good work, yeah. And that's how we would put down for our normal condition. Someone else give me, what's up, Fiona? Someone else give me what the mean world would be for normal condition.
N equals greater.
Thank you very much. I think I just spilled on myself, by the way. I apologize. Yeah, that's true, kind of. Can someone give me what the there's actually 3 different conditions that are there. All right, Ivana, give me the first one.
If the population is also normal.
Population is normal. Here's what I would say to this, because Ivana's right. This is the most missed part on these conditions here. It's easy to miss. You have to first start off, if it's normal, you just say population is normal, and then you skip the other 2. So it only needs to make or hit one of the 3. The second part, Grace, what is the second one? That's it. Good. Central limit theorem, which is n is greater than or equal to 30. And then condition 3
No skew outliers.
would be
Talk to her.
no major skews or outliers. Good. Ryan?
If when we graph, so like on the 9.3 homework, there was like a question where we had to graph to show that it was normal,
Yeah.
but it gave us like the numbers
Yeah.
on the answers.
Hey, let's keep it down so I
They were
can hear
supposed
Ryan.
to graph like the actual numbers. Are they gonna expect us to like actually graph it or just show?
Like,
If
I
they
would
already
say,
gave us the numbers, like, because it was like they did it as a dot plot.
if they already gave you the picture,
They already gave us the numbers like to graph. Are we supposed to graph it or can we just still?
I would say do a very rough estimate of that. Does that make sense? So like if I was going out and I just said, oh, maybe this is from 0 to 10 and it goes up, let's say twice there's 2 of those, but from 10 to 20 there's 1 of these, and from 20 to 30 maybe there's 3 of these. Just have a,
Use a different
You can use a different
color.
color. We can't see.
oh, yes, I'm sorry. That's probably bad choice. So if I was saying here from 0 to 10, twice that occurred, I just do something that looks like this, like a little histogram. From 10 to 20, maybe I say, oh, it happened 1 time. Okay, that's perfect. From 20 to 30, it happened maybe 3 times. Just showing something that's a guesstimate, right? Because you know it's not going to have a sample size that's too large, because if it did, it would be central limit theorem, right? So you would just do something that's approximate. Sorry about that. Does that make sense?
Yeah.
Cool? So that would be the third
So
condition.
we just plug random numbers in there? Is that what you're saying, basically?
Yeah, it would just, like an interval. They'll give you those numbers. Just kind of
Okay.
put an interval there. All right. Yes?
Okay, this might be a dumb question because it's like split up, but
You're good.
the proportion side, do we only have to do the law of large counts?
Yes, that's all I have to
You
do.
don't have to do the 3 steps?
You do not. Nope. So that's a really good question. And I think that it's not a, again, if you did do this over here, they take some stuff off, but it's not going to be all wrong. But I want to make sure you kind of understand this is only proportion world, right? So the mean world is the only one I have at 3 conditions. Does that make sense?
Yeah.
Uh-huh.
It's a great question. What's the formula for the mean of the sampling distribution?
P hat equals 3.
Mu
Mu P hat equals
mu.
Equals P. Good. And mu of x bar equals what, Torrance? Mu. Good. Nicely done. That's how we put it down. The formula for the standard deviation, so again, this is sigma of p hat is equal to,
Square root.
p times 1 minus p all over n. Great job. Charles, do you know what the sigma of x bar would be?
It would be S of X
over the square root of that.
Good. And because we use S of x here, this forces us to use what table?
Table B.
B, good. This is big time here. Because of S of x, we use table B, which is the t star. It's our critical value of t, right? Whereas over on the left side, we use table A, good. And this is on table A where we use our z star, our critical value for z. Bless you. Cool? All right, general formula for our test statistic. These are the same, okay? General formula. What would it be for our general formula, right?
I have a question.
Go ahead.
So this is back to the homework because I was kind of confused. They asked us to find the p-value, but like, okay, me and Mom were trying to do this, and we couldn't get like the p-value from like compared to the answers. And when we were doing TCDF, what are we supposed to plug in for T? Because I'm not getting anything close to like what the answer is.
That's a good question. Can I look at that in just a second? Because it's a great question. And this will show as we keep going. Is that cool? So as we go to the do phase, this is the general formula, which would be our test statistic equals our value minus our mean divided by my what? Standard deviation. Okay? That's for both. That's the general formula. General formula there. Now let's go into the more specific side. The more specific side. Did I mess that up? Do y'all need that?
Wait, I just
Yeah, we can go back.
Here you are. I know. Are y'all salty today? I apologize. Me? Are you judging me?
I was confused.
Wow. Wow. That's all right. I'll smile now and cry later. Here we go. Cry myself to sleep. There we go. Next one. All right. 9.2, the left side, proportion world. What would be the actual specific formula for that? What would I use for my specific formula? Well, let me make sure I say this first. Normal CDF with the formula, right? Or TCDF with the formula right here, okay, can replace what I'm about ready to put. But I'm going to do the z-score formula just in case. Charles, do you know it?
Oh, this is statistic minus null over standard deviation, right? Or is that-
Yeah, that is it. That was actually this right here.
Oh, well,
Statistic minus null divided by standard deviation. I like that. Can you go to the next one, which would be the more specific one? So like for this is z is equal to,
so it would be, yeah, p hat
yep,
minus 1, wait, I'm tripping.
what's the null?
P
P divided by?
divided by this, P 1 minus P over hat.
Good. That would be our z score for our significance test. Charles, you're good. It's good. What would be the T one now? What would that be, Yvonne?
X bar minus mu over S of x over radical n.
Radical n. Yep, that's exactly right. Good stuff. And that would be the specific formula that is there. Okay? Whew. Now I'm going to give you, this is what I would do. To Ryan's question, okay? Here's what I would do. This is just off to the side. In the do phase, here's what I would go here if I can reach this. Normal CDF, lower, comma, upper, comma, mean. What is the mean? Mu of p hat, comma, sigma of p hat, right? I would use that and then plug it in. Okay? That's the easy one. Over here, this one's a little bit tougher. In order to plug in TCDF is lower, comma, upper, comma, df, right? And remember, degrees of freedom is equal to n minus 1, the sample size minus 1, okay? Here's the issue that I think I probably should have been more clear on. When you do one of these, you cannot put in, and I put a little note here, cannot put in actual value. I have to use my t-score, okay? So let's say I was doing this graph here, because this goes to the picture. Let's say the mean was 10, okay? And I wanted to see whether it was greater than 10, and we were trying to find this as my p-value, okay? I can't put in, let's say this was 12 as my sample. I can't say 12 to 99999. You follow me?
Right.
I've got to use my t as my lower, and my upper would be 99999. Is that, you follow me on that? So I have to use my t-score here as my, in this case, my lower, and not just 12.
So T-score is like not a replacement,
I-
like using that formula, or
Yeah,
using
but-
TCDF is
No,
not a
the
replacement for.
If we use the T.
Yes, it's not the same as normal CDF.
We were trying to
Cool.
find
Yeah.
greater
And it's just the power of your calculator, really,
than-
is what it is.
Wait, so we still have
Yeah,
to
so
find T
it was-
before we
it
can
was
do it?
You have to find T before you plug it into TCDF. Cool? Over here you don't, right? You don't have to here. But over this one, you do.
So you have to do both steps on this side,
Yes,
Why
that's
is it
correct.
not-
and this one's optional.
I feel like
You do.
you still do it right
You do. So like in this example, if we're talking about mean, because that would be the mean world,
It was asking
I couldn't
about,
say
um,
12 was my test statistic,
so when
or
I
my
put in, I did negative 9999, and then
my,
the
sample,
T
statistic there
and
was
DF,
12,
I got
and we're trying to
like
see is
this.
this statistically
So I did
significant.
1
I
minus
can't
1,
say
I got my
lower is 12
But that's
and
what I'm
upper is
saying.
9999.
Why does it-
I would actually have to find the t-score by using the above formula
like
to then say that's the lower and the upper would be 9999.
Would you
you
get
could
it?
still put it. You could still put in like for this one, I could have put in 0.739999.
You could. So that one you could actually do lower, upper, mean, and standard deviation. You can do that one regular. You don't actually have to do the specific formula. But for the T, you have to use the specific formula on that. Gotcha, Grace?
So there's basically no point using
There is because when we do this right here, and I found, let's say I'm making this up, but let's say this had a T of 2.31
Yeah.
when I plugged it in my formula, I would still define this area, have to go back to my table B to find what that area is. Does that make sense? TCDF I like better because when I do 2.31 to 99999 and then whatever my degrees of freedom is, I would then just plug that in and that would get me what that area would be there.
Okay, so
Does that make sense?
we do have to know the formula for that.
This part you have to know the formula for. Yep. And that's why I would say star this and just know it. Because again, this is only in mean world that I have to do that. Only in mean world. Here?
So the T score is the P value, right?
Correct.
And you find it by looking for it in the chart.
Correct. You could find it using table B. I just know that table B can be kind of weird a little bit because you have to find where the t-score is related with my degrees of freedom, and sometimes it's not always perfect, and that can be kind of frustrating. So that's why I would use that there. Right?
Okay, I don't think I'm understanding. So, if the T score is less than 10, but you're trying to find the probability if it's greater than, or like, that graph, how, because this was what the example on the homework was, so I was confused. How are we supposed to, what was the point? I think she just kind of asked the same question, like,
Mhm.
why, I don't think I'm understanding it at all.
So if the null, let me give you the null. The null we'll say is mu is equal to 10, right? Okay? And the alternative is that mu is greater than 10.
Yes.
Our statistic, when we found the average of whatever it would be, I don't know, whatever we're thinking, was 12. Obviously, this is higher than what 10 is, but is it statistically significant? That's the question, right?
Yeah.
So then we look at this and say, okay, 10 is the center. 12 is out here, and we're looking for anything greater than, and we're trying to see, is this p-value show statistical significance, right? So we look and see, in order to kind of set this up, we use whatever the t-score is that we find. In this case, I just made one up, 2.31. And then I say, okay, what's this area? And I can find that area once I find the t-score from the formula by plugging it in for TCDF.
So it doesn't matter if the T score is less than 10. Do you? I don't think. Are you understanding what I'm saying?
What does t-score mean? The amount of standard deviations, in this case above the mean, right? So we just say it's 2.31 standard deviations above
Oh,
the mean.
okay. Okay. I get it.
Does that make sense? We just have to find this in order to plug it into the lower part of the formula. It's out of ink. I don't know what's up. There we are. Yeah, that's it. Yes. Here.
Wait, what do TCDF give you?
TCDF gives me what the area is.
Oh, so that's not there.
That's the p-value. Is this helping?
No.
Yeah.
No, I mean like no, it's helping. Like
I
no,
understand.
it's helping.
I thought you were like, no, it's not. That's all right. Some people are critical today, right, Grace? But that's it.
Okay, call me out again.
Yeah, you got something towards?
Is p-value the same in both the proportion and the mean world? Like, did you still use it for both?
Say it one more time. I want to make sure.
Do you use p-value in both the mean and the proportion?
Yeah, p-value is just the area of the shaded area region, right? If it's less than my alpha level, statistically significant. If it's greater than my alpha level, we do not have convincing evidence, and it is not statistically significant.
Okay.
Does that make sense? Cool. All right, hey, last part here. Y'all have been great. I hope this, again, is helpful, just putting everything together. Remember, this is degrees of freedom. This is just our picture, okay? Over here, when I do this picture here, remember big N, mu of p hat, comma, sigma of p hat. That's kind of our notation.
Wait.
All that means is we've got our mean and our standard deviation. So our mean on this is always equal to our whatever our true p is that we say in our null hypothesis, okay? And then we shade an area that's there. What if I say it's not equal to? What does that mean? What if I say p, and this is my alternative, right? What would I do with that, Hannah?
Wouldn't you shade in like two directions?
Correct. So I would find first one, and then to find the actual p-value, I would just multiply that by 2 to get to what it would be at the very end. We could do a problem like that later on if need be.
What if you're in mean world and you have to do that, and you have to put a lower and an upper? How do you include the middle part that you don't?
Yeah, so like over here, I would find this p-value first,
Oh, you just
and then I would just multiply by 2 to get what the other one would be. Good. So if I change that to not equal to, that's what I would do there. Cool. And then how to find my p-value? This is table A, or normal CDF. And I already kind of said this, but just in case. I then use over here table B, or TCDF. Cool. And then the 4-step process, we look down on those 4.
Is there gonna be a question where you make us do table A or table B? Like we can't use like where you're not.
The only time that would ever be required, FRQs never. The only thing I would say is just be familiar for multiple choice. You know what I'm saying? If they have you work backwards or something like that. I didn't see one like that on this test, but that doesn't mean that it won't or that the AP exam won't. So just be familiar on how to use it, kind of sort of, but for FRQs you could always do this method, either one of these. Okay? Cool. Time-wise, how are we doing on time? We got 7 minutes left. Okay, I'm going to do something different. I was going to do this tomorrow, but I think this will be good for today. I want you to go ahead and take out your FRQs with someone that's around you. I want you to do it with them. I would do it right on here. Normally you could use the whiteboards, but do it right on here. And what I'd like for you to do here is to go ahead on the very back side and do 3A. Okay, 3A, because it asks for statistical significance. Go ahead and do the 4-step process out. Tomorrow we're going to have a review game when you come in over the multiple choice. So we'll do some of these in class, both FRQs and multiple choice there. Okay?
Do we need a podcast stuff to do this?
Say it again.
Do we need a podcast stuff to do it?
I told her first time.
Yeah.
I think I did.
Chloe, how was your
No, I
mission?
mean like, did you see
Some
what
of the portion.
I can see.
on like
Hey,
the
fuck
open
my
Oh no, not this one. No. The
It's like my
the
favorite.
power stuff. That was the brain.
Oh my gosh.
Are you looking for some keyword there?
Yes, there's like the trip in general.
She got a child, like, child.
No, I know some people do it. I just,
Huh?
I don't know groups. I'm like, some people, I live not.
Like Chandler. Oh, you did?
Yeah, some of that made me sick, not gonna lie. Me, like, people were literally like talking about it. Like, the kids are like prompts.
Yeah.
Like,
Go ahead and just turn that into that. Just and don't even have to. I'll give full credit because I know people on mission trips. The goal was yesterday, but just give it to me by tonight so you can study tomorrow for the test.
Wait a second, say your breakfast better.
We could do that. You know how embarrassing.
I'm not kidding. I wish I was 10 kids.
Let me know if something comes up.
I think I got favorites, and I let people.
Thank you for that. I think we
Hilarious.
So yeah, it was like some pictures that people posted were like super edited, super like.
Oh, you get ranked?
It's really fun.
She's iced out, coach.
Oh.
Awesome. How excited are you?
So this is a 14.
Yes, it is.
And then, like I said, like, you go ahead, last year, remember,
So okay, so the parameter.
Okay, kids.
I got
Congratulations.
parameter
That
is
is so
my
cool.
Wait, what's
See, my calculator's not out, so like.
All right, let's get it. Let's go. Here we go.
Because
You've got questions. I've got answers.
It's supposed to be even, so it's 0.5. How is P equals
Guys lost, so that was kind of sad.
I heard
Oh,
about that. But instead it's just like that's the statistic.
Oh,
They said that it was
yeah.
still like a good like it was
It's a duration, and then the other one is
Coach
P
Jake,
is not equal.
I miss those guys. I'm gonna miss those guys.
Yeah, because now it's over, right?
Yeah, I've been with that group since 8th grade.
Yeah. That is sad.
HFA more time for me.
What's that?
More time for us. Get that next
So
one.
are you?
That's true. Oh yeah. You go hang out.
Wait,
There's Jay. Thanks, Kate.
No, I was saying the trip.
okay, wait.
Okay, is the true proportion of male
Stinks.
births and
Firstborn boys.
These, do we have to put them in context, like the hypothesis and the alternative?
Yeah, so you put P is equal to 0.5, right?
Yeah.
And then P is not equal to 5, right?
P or P isn't.
Yeah, but remember to define what P is, right?
Oh, yeah.
P is the true parameter,
True parameter, yeah.
parameter of what?
the weekly test.
Oh, I did so.
So how is this whether
Wait, is H
So
of
P, so the parameter is population.
Male,
That's the number.
Yeah.
But that's not good, that's not.
That's the statistic.
Yeah.
Yes, sir.
Yeah, man. Okay, wait, what is the no?
yeah.
Because we're
Oh,
trying
because,
to
yeah, because we're trying to present it. So, wait, coach. Since it's not even?
Yes, sir.
I saw.
not even.
I mean, I don't have to double. I don't have text us. So I can't.
I think it's
So.
boys are like all the first. I think it's.
That's right. This was just turning late. So should we would you mind putting on the left side for me? Just on the back side, and I'll update that. You're right.
Wait, how many teams are there? Are you guys using those?
Yeah, it has
Are you using the forecast?
Yeah.
Okay,
a
yeah.
big number.
Wait, was that the World Congress?
That was the last. That's one of the tests that-
For this, the P,
We have to write one sample.
it's
I already did.
One. So
Since like
statistic,
or like the number of boys out of the all
statistic is
Okay.
the predicted proportion.
So
So
we need
yeah,
to
so
do
2,500 would be
P
the.
hat
Good.
So like
Yeah.
all the tests and stuff.
5. But we know that the thing of P P hat
Correct.
is 0.53.
Correct. So, and then also, Chris, I think I saw some on yours. The issue would be
Like,
0.5.
P hat equals 153. Mu P hat
Because it
equals
takes it from the
153.
null hypothesis. Does that make sense?
What do you put in for that?
So
You
whatever
got
you
it.
see for any type of T,
Okay, and then
the
Your purposes, we hypothesis stand up
here. The line should be.
Oh,
I'm
no.
just kidding. I was looking for
that's why you're
Well, not all of them. In this case. So this, yes, this would be 0.5. These two.
Like, cash all off the card.
Dude, he was on your little trip.
Hey, y'all, check out that podcast and have a great day. We'll see y'all later.
Thanks, Coach Jay.
I'll see you on Saturday.
Oh, you up?
Yeah.
Are you up? Yeah.
Yvonne,
No,
have
I'm
a good
going
one.
to my sister.
See y'all.
Yeah.
Josh on Saturday?
Really?
Yes, it is.
I was going to, but then I was like, I'm already. Are you gonna watch it?
Yeah, no, not do that.
I didn't realize it was an
Apparently it's
awesome
a
Yeah,
super
no,
long.
no, no, no.
Stealth only.
It's basically a battle.
Stealth in the first half, so I don't know what was in the second half. I just want to stay. I want to see the pressure. I want to see the
Translated to pay, give money.
all the guys.
The voting was.
Yeah, I talked to the guys
With the
today.
voting contest, I think,
Honestly, I do Friday mornings because I
Yeah.
have duty, but I can do Friday after school
Oh, you can- okay, Friday.
because of no basketball and stuff. So we can do Friday after school if you want.
Okay, this is just fun.
How was it? Must have been.
You must
Yeah.
have been doing something.
Must have been.
Wait, I didn't hear
You
if
can
you
do
said
it.
like a due date
Come on,
for the
tomorrow?
date and stuff. I know
You
it
can do it tomorrow?
was like more for
You
you,
can do
but when is that?
It's supposed to be this
Why?
Friday.
Friday? Okay.
Really, it's just I want to make sure I had a
Me too,
deadline because I've been on them.
Yeah.
Like, hey, we need the data, we need the data. So I'm trying to get it to y'all by this Friday.
Okay.
So you should have it in your hands like by
So we
Friday.
just have to like print it out and like bring it to me. Okay.
And really, you don't even have to show it to me,
Good.
just so that you've got it. That's all I need.
Oh,
So. Thanks, Kristen.